I joined Bjarke Engel's group as a structural engineer, and later I joined the high-rise department of Ramboll, where I came in a role as a computational design lead in the buildings department. And now I have started my own consultancy. So I have my consultancy, Timo Harboe, and at the same time, I run this learning platform called Python for Structural Engineers. So just to give you a little overview of a few of the projects that I've been working on, from this beauty here in Milan to high rises in Denmark to art installations in the US, smaller innovation projects, a quite wide range of projects. And what they all have in common is that I have used Python in all of them. So the agenda, a little bit of introduction. Why do we talk about this Python stuff? Then I'm going to get past that very quickly and get to all the practical examples. Then a suggested learning roadmap, like how do you get started with this? And then we're going to end up with some Q&As at the end. So I learned Python many years ago, but never really learned to apply it to structural engineering until I came to this project here. So we had a project where we had to do a lot of iterations. The graphs over here are not from that exact project, just to say. But we had to do a lot of iterations, and I had some really frustrating processes with data from our finite element models. I took a course in data science for engineering, and that kind of opened up a new world for me. And that is what has ended bringing me here today, because it's such a game changer for the way I worked. So I said, it's not about being a programmer this year. If you want to do that, fine. But this is about engineering, how you can use programming for engineering. Essentially to spend less time fiddling around with data and doing things that are really boring. So like data handling, repetitive tasks. There are a lot of things we do that the computer does a lot better. And that's what it's about. Take control of your computer. Then why Python? There's a lot of ways to do that. One of the things I like about Python is that it's very easy to read. Like here's an Excel formula. I know this is a bit caricated, but this one over here, this Excel sheet does the same as the Python code you have over here. So Python is really quite simple syntax. Also, if you have Excel sheets or Excel templates that you already use, well, you can use Python scripts to inject data into them. So you don't need to necessarily rewrite everything, but if you want to loop over existing Excel templates, you can use Python to help you with that. So reasons why I prefer Python over many other options is that it's easy to read, easy to QA, has a simple syntax. It integrates quite nicely with Excel and spreadsheet data. You can break down the code, like you can reuse fractions of your code by writing code in modules or functions. And there are lots of external libraries that are being downloaded millions and millions of times and can help you with a ton of different things. And it's very easy to use various AI tools to assist you both in learning and writing code. Then I just want to show you how it has increased. Like it's the top 10 fastest, it's the #1 fastest growing language in 2024. From the Technical University of Denmark, now all students learn Python. Jupyter Notebooks, which is a way of writing Python, its usage is exploding. So this is really only growing. So I want to focus on this here. Learning Python is not about learning how to use a new tool. You have to learn how to use Python, but it's about unlocking how you can work with the tools you already have, like the finite element software you use, Excel, whatever tools you use on a daily basis, and your computer in general. So that brings us to a lot of practical examples. So I'm going to go back and forth. I'm going to close this one here. And then I have a folder over here where I'm going to drag and drop stuff over onto this screen here. So first, I just want to show you an example of what this Python code looks like. So You have on Google Colab is a service provided by Google. You can write and run Python code online without installing anything. So you can just go like search for Google Colab and you're ready to start writing code. And this is what code can look like. You can say header, this is code. Now I need to move this away here. And you can see it updates over here. Now we've updated the text. You can write explanatory text. You can write formulas. And then we get down to some code here. So just to show you an overly simple example, we have an area of 200 square meters, a load. We calculate the total load by saying A times load, and we print the load out. And we have now run our first little Python script. So if you're already used to some other like MATLAB or similar software, it's very similar to how we do that. Something that's quite useful is also that you can define functions, this like modular approach. So for example, you can calculate the total load of an area. I say, well, this function needs an area, it needs a load, and then it calculates area times load. What's cool about this approach is that if you write a little program, for example, that calculates capacity of a beam, you can put it into a function and you can reuse it again and again. You don't need to copy stuff around and rewrite things. So you can see if we run this, we use a function instead and we get the same result. I also want to say, like, of course, this webinar, I don't want to show you in details the syntax of Python. That's not at all what this is about. I want to give you an idea right now of how it's written, and then I want to show you what you can do with it. Syntax takes a little bit longer to learn than a 1-hour webinar here. But this here, you can define functions, which is really useful. And something else that is really useful is that you can loop over different values. So let's say that we have this area of 200 square meters, and we have the load 2.5, 4, and 5, and we want to run the same code for all of these values. Then we take each of these loads and run it through the same piece of code. And first, it calculates for the first value, then it calculates for the next value, and for the last value, and so on. So if you compare this with the way you work with Excel templates, often there you can type in one value, and then if you need to do any checks or something, well, then you do it then, and then you can put in a new value, or you have to work in a strictly tabular format with one row for each calculation. And in that sense, you can set up some pretty amazing calculation templates in using Python. And let me show you one. So I have here a template for a beam design. So I've written a little notebook where we go through the design of a beam according to the Eurocode. So this is how code can look. Like sometimes when you think code, you think something that looks out of the matrix or something. But here we have explanatory text, we have headers, we have a good structure, and then we have all these code cells here where we can write the geometry properties, we can write our material properties, we can run the code cell after cell. And as we go through all these cells, we define our design factors. Then I'm actually just going to run all this code and take you down to the bottom where the fun part comes. Yeah, you can also place images in your code, mathematical formulas in your code. So this is here is a piece of code that you can actually give to a colleague who doesn't necessarily know how to program, and they can QA this. And I'm going to show you in just a second something that makes that even easier. But I want to get down here, because let's say you're doing an optimization of something. You want to see how many bars of a certain diameter do you need to satisfy a certain moment, or get the utilization as close to 100% as possible. So I'm not going to go into the details of this code, but what we're doing here is that we're taking all the code we've written above and we're looping over it, and we say, now I want to test this whole beam check. I want to check it in the case where I use 8mm bars, in the case where I use 10mm bars, 12, 16, 20, 25mm bars, and so on. And I want to optimize each of these solutions to come close to utilization of 100%. So I can see, okay, this beam would need either 9 number 8 bars, 6 T10 bars, 4 T12 bars, 3 16 bars, and so on. So this possibility to run your code multiple times allows you to optimize and spend a lot less time repeating calculations. And now we talked about this thing with QAing stuff and making readable code for your colleagues. Here you can see we call everything depth in millimeters, and we type the value in millimeters. We type the value here in megapascal, and we have to keep track of the units ourselves. But as I said, there are a lot of amazing libraries out there. For example, there are 2 libraries called handcalcs and for all people, written by a guy, Connor Förster, who contributes a lot to the open source community as well. What those 2 packages allow you to do, if we just go down here, scroll down a little bit. Let's go down here, for example. Exactly the same code as I showed you previously, but now we have our material properties listed here. We write it as code. But when we show this report, show this script, it comes out nicely in the units we have chosen with the comments we provide here next to it. So suddenly this sheet of code becomes something that anyone in your organization that knows how to QA can QA. So you can give this to a senior engineer who has no clue about Python, and he can still go through this, or she can go through this and understand what's going on. So we get rid of this black box that these things can sometimes otherwise be. So here you can work nicely with units. You can format your calculations nicely. And that's about what I want to say about like reports and these like calculation templates that you can do with Python. So that's one thing you can do. But as I said, it's about using your computer to the fullest. So let's just take another example. Let's say that you have a folder here. Now I have a folder. Inside here, I have a lot of subfolders with files in it. And let's say that your manager has asked you to just once a week let him know which files have been changed in the last week, and just send you an overview of the folder structure. This could also be that he wants a drawing list, a document list, or that she wants to get something else from you. Whatever you can think of that would take a lot of time to sit and compile Friday afternoon. What I then did for this example here was that I went in and I just set to ChatGPT actually. I went in and I said, hey, write a script that extracts a nested folder structure of a folder and opens an email with a file list. Use standard libraries to the extent possible. Then ChatGPT gives me some code, and because I know Python, I can go through this and change what I need to change and see if it does something that's not correct. Because these things may work, but you need to understand how they work. Otherwise, you're going to end in deep trouble and dead ends. So I go a bit back and forth with ChatGPT to write this code for me. And I'm going to show you the code in action now. So we have a script here. We call it the mail-to script. So all I need to give it is I give it my base directory, my folder that I want to check the nested structure for. It's a test folder. And I say I want to check the last 30 days, any files that have been changed. And this here we don't care about. And then it runs this little piece of code, and I run it. And immediately what happens is that Outlook opens, and I can see here I have these files that have been modified in the last 30 days. I can send that. I already have the project manager at the company I work for.com in the to, and I have my whole folder structure listed down here. This is just one example of what you can do. You can think of many other examples, like, yeah, you need to do a document list for the project you're working on. You can also do that. I'm gonna close this one here. So this is about, if there's something to do, I have to do this again and again, and it's really a bit boring and simple, you can most likely write a Python script to help you out. Now, something else that I had to do on a project, I was writing a report about vibration, And I was using the CCIP 016 vibration guideline. And there's one of like this plot that shows like the uh, acceleration in a building, how perceptible it is based on the frequency. And I came into this document, and the figure here just frustrated me. I made a really beautiful report, I thought, and then I had this figure that was a bit pixelated and things. So I thought, actually, I'm going to do this in every project we are on. So I'm going to make a little template for a for visualization of this. So I went in here. Oh, I'm just going to turn this down again. And wrote a template that can help me create this visualization. So again, I've written it with links to the resources that the reader of the script may be interested in. I have an explanation in here about the response factors. I put in the formulas that I'm using. This is overkill for most tools, what I'm doing here. But this means you can take the script and use it straight out of the box. I put the calculations I need to do in here. Let's just run all this code here and get to the fun part down at the end. So first I make one plot. I see this is definitely not what I was after. We need to tidy this up a little bit. I tidy the plot up, and now we are up. Let's see if I can zoom out one bit here. Yes. This is essentially the plot we had before. But what I've changed here is that I've also put in the limit for my building. I know I have a response factor of 4, which is my limit. So I've also added that to my visualization. And because it's a template that I can then change, I can also say, well, I have another limit for another building, and maybe a response factor of 8. Then that would just plot instead. And if I've done some analysis and I have some points I want to plot, I can also put those in to the same plot. So you can get a really high quality visualization. You write the code once, you write it with help from whatever AI tool you have to help you, and you can create a template like this extremely fast and get really high quality visualizations out. Which brings me to that another type of problem that I encountered. So on a project I was working on, we were designing this raft, what is called a floor that swims on styrofoam, like a thin concrete slab that is supported on styrofoam. And there I needed to optimize the thickness of that slab to really minimize it as much as I could. But because it's on springs, essentially like this example here, the optimization process gets a little bit tricky. Because like I know that the styrofoam has a certain capacity that I need to satisfy, and the whole thing is depending on the stiffness of the concrete. So I actually just wanted to run a lot of iterations on this. And now I just put in an example here where we build a finite element model inside Python. So in this script here, we define a full script. Let me just run the whole script here while we wait. So I define my my finite element model with text here. This is something you would do quite rarely. I just want to show you that it's possible. You define a finite element model here, and then I can loop over it as much as I want. So get down here to the bottom, because I think these results here are the most interesting. Here we are. So this is a non-linear model where this here shows deflection and reactions. And I'm looping over different stiffnesses of beam on top of these springs. And you see the springs are compression only springs. So if I have a very, like not very stiff beam, you can see I get very concentrated reactions in the middle here. And as my beam gets stiffer, the reactions spread out more and more. And you can also see the deflected shape here. Here it like pokes really down into the styrofoam. And as the beam gets stiffer and stiffer, we get a flatter and flatter deformation of this. This is, of course, also something that you could link directly to the finite element software that you use. You don't have to write a finite element model in code. That's rarely what you want to do. But you could link it to the finite element software you already use and run a similar analysis. And again, you can automate these visualizations, and you can just like click here and say, save it. or you can automatically save it. Then one of the things that I have used Python for the most is related to finite element models. What we often do with, like when we have finite element models, we have a lot of data. We have a ton of data, like sometimes several gigabytes of output data from one file. We want to do variations of models. We want to change properties inside a model. Like there's a lot of things where we sit and click around, copy paste data from finite element software to Excel. We click around in the model, change spring stiffnesses, and change things very manually. Often we do that because it's we're going to say it's safe, like you're fully in control of what you do, and that we need to maintain. But I believe you can do that with Python as well. So first, I'm going to show you how you can work with input to your finite element models. So like there's the pre-processing of your model, and there's the post-processing. So let's first look at pre-processing. So here I have a robot, Autodesk robot model. So most finite element software allows you to import and export your model as text files. And this is something I've used actually quite a lot. So here you have a very, very simple robot model. You can see it's defined here with some nodes. So you have X and Y and Z coordinates. You have some other elements down here. You have some bar elements. Like you have a lot of properties defined here, and you can load this file into robot and it will build your model. Now I have made this file just for the sake of presentation. So what you will see here is that the person who modeled this have not been modeling it completely precise. You have some variations in the points, like this here should be 3 meters, but it's 3 meters and 9 millimeters. Like there's a lot of variations from some of these here. Sometimes that's what you want, but maybe you had some grid lines that you want to snap to. So let's say you wanted to take this model and you want to snap coordinates to grid lines if a point is close to a grid line. This is something that you can do in robot if you then sit and move the points manually around. You could also say that you just round values to the nearest meter, but that's really quite risky as well. So what I did for this, let me just go down to the correct spot here, 1.4. Here. Oh, we go up here. So I say, like this is my logic that I define. If and only if a point is within 0.1 meters of a grid line, move it to be on that grid line and report to the user you have the distance you have moved the point. So if we do any changes, we communicate to whoever is using this program that a change has been made. So now here I define my grid lines. I have X grid lines in 0, 3, 5, 8, 10, and 11, and I have some Y grid lines as well. Again, this is a simplified example. Your data may look completely different, but it tells the same story. So let's try to run this little piece of code here. So now we have actually opened this text file that we saw here. Python has opened this file. It has been scanning through the file. Then I have told the script that when it reaches this point nodes, then it has to go in and edit these points here, and everything else it should just not touch at all. And in this section, it should round the numbers to the nearest grid line if it's close to a grid line. So let's open the updated file. So you can see it here if we just put them side by side. You can see that the grid lines we had no negative grid lines. So these two first points here are actually unchanged on this grid line here because there was no grid line. We didn't define a grid line. We actually did not want these points to snap. Also down here, you have some points that didn't snap to anything because they weren't close to a grid line. Everything else has snapped to the grid lines we wished it to snap to. So this can be a really quick way to do some quite complex corrections to your models if you have some inaccuracies. But it's, I want to reiterate, it's extremely important that you like make the program write out what it does. Like you don't ever want it to change anything without your knowledge. So this is about like changing these input files. And I have a very real example of that as well. I worked on a high-rise tower at some point where we had a lot of iteration back and forth with the geotechnical engineers. It was on a weekly basis. We would send them new reactions and they would send us new pile stiffnesses, new reactions, new pile stiffnesses. So I made an agreement with the engineers about the format I wanted their data in. Like they had to send me an Excel file with the new pile stiffnesses in a certain format, and then I could go in and automatically update my ETABS file. It was ETABS I used for this. So I have the same thing for ETABS. Let me just open a file and show you here. Text edit. So it's a similar problem as the one we had before. File looks a little bit different, but it's again a full fine element model described as text. And down here you have all your points. And if we go further down, you have what you assign to the point. Here you can see we assign a spring to a point, and you have some spring properties later down. It's not the details of this that are important, but you can see it's a relatively large model we have here. So we write a program where now I just like hard-coded these values here, but let's have a look. So let's say that this is the table I get from my geotechnical engineer. So there's pile number 3 has a new pile stiffness of this, pile number 5 has this, pile number 6 has this. So they have some unique identifiers that we agree on. And then whenever I receive this information from the geotechnical engineer, I click here, run all. Oh, I need to go past here. Oh, sorry, just take this one, and then we can run. And you can see over in this folder here, immediately have come, I had only this file before, now came this one as well. And inside this file, I now have, if we just search here, spring prop, you can see down here, I have now assigned a spring property to all of these points. To point 144, I have assigned spring property, spring type 144. And if we just like take this one, control copy, find that. Down here, you can see we have defined all the springs with their correct spring stiffnesses that we got from the geotechnical engineer. So now this here takes me 2 minutes to do every time I get a correction or an update from the geotechnical engineer. I don't need to sit and fiddle around with anything. So this is something I have used a lot for this. Yeah, back and forth, something I need to do again and again. There's no need to do it manually. So that is pre-processing. That's one thing. But my key usage of this here is post-processing. So there is a package for Python. Like Python has all these libraries, and there's one that's called pandas that works with spreadsheet data. So what you often get from your find element model is stuff like this here. Just see, it's a pretty big file, this one. So you get this out, and you have all these different sheets. Now I've just exported everything. So I have element forces in my beams and my columns, a ton of data. And I remember at one point, we had this template where I worked, where every time we needed to do something, I had to go in and I had to copy this data out. I had to copy some other data out and copy it into our Excel template to get the stuff out that I wanted, which is super error prone. It takes a long time, and it's not really that interesting work. Then I had a project where I had to do sensitivity analysis. I had to see what happens if we change the concrete grade. What happens if actually the eccentricities in these columns are bigger than we expect? What happens if? So I had to make a lot of models and compare them with each other. So let me just open a script here. So this here is a similar thing as I've just talked about here, but a sensitivity analysis where we, for example, compare mesh, what's called resolution. I want to see what happens if I make my wall resolution finer. I want to compare these things. And I don't want to just only compare a modal period or something. I want to compare whatever I would want to compare. So let's try to run this script here. What the script here does is that it takes two Excel files. It takes my like an Excel file named this, and it takes an Excel file with this name, and then it compares these files like with my logic. So my logic, as you come down here and see, is I'll just go to the logic first. I want to see the difference in reactions between these two models. I'm interested in like, how does it affect my piles under the building? So here I can see, well, I have a model here where I've decreased, this is not the mesh, this is the stiffness. Sorry about that. I've decreased the stiffness. I think it's my pile stiffness. I've decreased that by 15%. How does that affect my pile forces? And I can see that these here, they grow by about 50 kilonewtons, and these out here decrease by I guess 35 kilonewton. I also have a percent-wise decrease. So I can make all of these diagrams here completely automatically. I just make a new file, export this Excel data, run this script again, and then I have all of these plots here saved in a folder. I can see, okay, here I have a nice plot I can send to my boss or put in a report. I can also, this diagram you saw before, make a really nice looking reaction plot of your model, where like with a heat map that shows both the values and the distribution of forces. Again, a visualization template that really shows really well how your building works. So sensitivity analysis is something that I can never imagine doing again without Python. It's so extremely useful to compare these models. I don't think there was more in this file that I wanted to show. So the key message is here, you can automate the output of all these visualizations, and whatever visualization you can think of is something that you can create pretty automatically. What I discovered when I did a template like this in my old job was that a tool like this started spreading quite organically in the company. Like people are like, okay, yeah, this is pretty smart. This is something I also want to use. And I had one engineer in the team who started very actively also using ChatGPT to change this script himself because he wanted to change the colors, change the size. And without any Python knowledge, he could actually change it and adapt it to his needs. So let me get to one more example. Let me just find it over here. So again, this thing about showing your data in a nice way. So here is another example. It's going to run this whole script here, where I load in one of these files here with all the output data from our finite element model. I process the data a little bit, and I get down here. Just run some of this. Oh, not this one. From here and down. And what I want to show is I want to create an overview of the column forces across all floors in a nice, intuitive way. So let me get down. Like this document you're seeing here is a guide on how to do it. So there's a lot of repeated stuff. What we're interested in is this one here. So here I have now made a template that every time I have a building, I can just run this script and I can see how a certain column stack varies down throughout the building. So now you can see all your columns, how the force in them vary from top to bottom. And now I start to see some quite interesting things here that I would want to be able to explain. Why does column C16 have like a parabolic change here? Like, this is very different from these other columns that seem more linear. Why is this? I want to be able to answer that. Same with C13. Why is there a cutoff here? Like, why does story 2 have the same force as story 1? This here helps me understand my building. You can visualize it like this. You can also visualize it like this here. Like, there are tons of ways to visualize these things. And write the code once and use it on any project you work on. Then, okay, I want to show one last example. So this is again back to this working with files on your computer. So this could be, for example, you have a folder full of site photos. Now, just like made some dummy images here. They're taken on different days, have different names. And what I want to create is I want to create a folder that contains all images that are taken on the same day. And I want to create an Excel sheet where I can provide comments for each photo. So let me just go in here. Let's take number 2, it's down here. Yeah, here. So the task is create folders named after relevant date and move each site photo into the corresponding folder. Photos taken on the same day should go into the same folder. So let's see if I can just run this here. Oh, I need to run everything I see. This, and I just also run this here. Now we go back in here to our site photos. And now you can see I've created a folder with all my photos from one day, all my photos from another day. And I have this nice little Excel file here where I now have the date for each photo listed, and I can write some comments out here. So this here, I didn't write a single line of this myself. It was a prompt. It took me 2 minutes to write the script. That's really the power of learning Python now compared to learning it 10 years ago, that it's a lot faster to write and learn. This brings me to the end of our examples. And I want to just, like now I've shown a lot of things. I've been shooting a lot of different examples up just to give you an idea of what I think is worth learning. Take a screenshot of this if you want. I really recommend that you start just getting Python fundamentals down. There's a lot of resources for learning the fundamentals of Python. Then there are a few libraries down here that are interesting to look into. But Python fundamentals is what you need to learn anything else. And then there are my 3 favorite libraries is Matplotlib for creating visualizations. It's the OS module for working with files on your computer. And it's Pandas for working with spreadsheets. Matplotlib and Pandas work very well together. So if you learn these 4 things here, you can do 99% of the stuff you will need in structural engineering. Using AI. A few tips for that, because it would be stupid not to use it, but you can really quickly dig yourself down in a deep, deep hole. So I say use incremental prompts. Start small, I like to say, write as much as the logic you can, and then get the AI to solve small little problems that you yourself kind of know the answer to already. So start small, refine it step by step. Ask for explanations. You need to understand why it works. Otherwise, you have absolutely no chance of correcting it. If you can't explain your code, it's useless because it may not work as you expect it to. And then your focus should be on structure and data. Like when you have something you want to do, like what is it you have when that process starts? It was a file of folders. What is it you want? You want more folders and you want an Excel sheet. So if you can define input and output, then you can get AI to help you fill in the blanks. Oh, let me just see. And then I like this way of looking at it, that the most precise way to describe a solution to a problem is with code. Often you say, I'm just going to ask ChatGPT to help me solve this problem, but you can't often describe your solution well enough just using words. Like if we look at the Euro code, any like pretty standard, everything there is very clear in code already. It's like if this, then that. If this, then that. And that's how you should also write your prompts. Write maybe not the right syntax, but the right logic. So it's a way of thinking that you need to learn more than actually a syntax to write. Then I briefly here at the end want to say that I have a course in this, Python for Structural Engineers, where enrollment opens on the 18th of April. So I just had students from over 50 different countries through when I opened up last year, and now it opens again here in April. So you can sign up on the waiting list on pythonforstructurelengineers.com. And if you have any questions to this, please don't come with them now, but just send me an email. There's all the contact information on this webpage, so just send me an email and I will reply to everything there. So I think that brings me to the end of this presentation here. So I'll just close this down.
That's brilliant, Timo. Thank you very much. I've been keeping an eye on the questions in the chat, so it's okay. I'll rattle them off for you. So I think that one of the first questions was actually saying if any of the examples from your PowerPoint presentation are available. Just to keep the chat technical, any questions, again, just forward them at the end. We're always happy to answer them and see what's free for distribution. But there was a question early on at about 12:20. So that was from Newman, who said, which library did you use for the FE analysis? I think this was for the pile spring question on the raft.
Yes. So I use a library called Finite, FEA, which is fully open source. And it's like undergoing, like it's just come out in a 1.0 version, which means it's quite stable now. So yeah, Finite, and it's a really awesome package. But I would still recommend, like if you're going to use finite element analysis like I did here, it's worth looking into kind of like APIs and connecting directly to your finite element software.
Perfect. Another question, did you use anything specific to format your Jupyter notebooks like widgets, etc., or simply just its own markdown cells?
No, I did not. I'm just using Visual Studio Code as it comes straight out of the box. I've not really done much. Like there are some of my notebooks where like I formatted using normal markdown. But other than that, it's as it comes out of the box, except for where this one I showed that had rendered really nice calculations. That was using the package handcalcs.
Perfect. A question from Thanos. Which IDE do you recommend for Windows, Microsoft versus or Microsoft VS or other?
This is one of those questions that a lot of people have strong opinions about, and most of the time say whatever makes you happy. I personally always suggest that people start out with Anaconda and using just Jupyter Lab there. Reason being that when you install Anaconda, it's extremely straightforward to get everything to work. Just like find a YouTube tutorial, install Anaconda, and you're basically ready to go. I personally use Visual Studio Code, which is a really good IDE. If you just want to try Python, and be like, oh, this could be quite interesting to try, and you want to give some prompts to ChatGPT and run them, then I would suggest using Google Colab, because you literally just go in and start programming.
Perfect. Question here, it might be popular in the UK. You mentioned you use etabs with Python. In the UK, we also have Tekla quite a lot. Do you use Python with Tekla programs, or do you know if you can use it with Tekla programs?
I would say it doesn't matter what software you use, as long as it can spit out some tabular data. And if you work with some like FE software that can't give you tabular data, I think then there's a much bigger problem. So it can definitely work with that. I got to say, there are some software packages that have lower quality tabular data, where you sometimes need to do a bit more cleaning up in the data. Fun fact with etabs, for example, was that they had decided at one point back in the days arbitrarily to remove some values if they were less than 2% of the max value or something like that, which meant I had holes in my data and none of my automation worked, which was super frustrating. But most of the time, like it works flawlessly with whatever software you have. You can, or just to add to that, you can also upload a dummy file of some of this to, again, ChatGPT and say, please write a script that cleans this up so I end with these columns. Be very explicit about how you want it cleaned up, and then you have a pretty good template for how to prepare your files and get them into pandas.
Okay. Another question, Konstantinos asks, if I wanted to create a calc template with a sketch that changes according to the input data, is this possible? Let's say a connection design. So there are a few graphs, but can we do sketches as well?
Now you're getting into the tough stuff here. There was actually, so recently, a student that has been through my course who shared something with me where he had done a calculation of some like eye sections of beams, where I showed the effective section, like basically like the whole like imaginary hole there is in the section, and he had shown all of that with dimensions and stuff, so it changes dynamically. So that's possible, but you need to write the whole figure from scratch. Like it gets a little bit. I would not go there most of the time. I've got to be honest. Yeah, no. But this example was really awesome because it was a cross section, and a cross section is easy to create with matplotlib. It's easy to put dimensions on, so that makes a lot of sense. But
Yeah.
if you want to show a connection detail or something, like no, there I wouldn't go.
Okay. Another question now. In the company, so this is from Edson. I take it that his company won't let him install any programs onto his laptop. Would Collab allow him to use these packages online without having to install anything? So that's Google Collab.
Yes. So this is actually when I first started like going into this whole also development of my course. This was one of my biggest concerns because you may want to use Python, but then you meet your IT security team and they say you're absolutely not going to install Python on your computer, and then you are pretty in a pretty bad situation. But everything I've shown here can run in Google Colab. There's no need to install anything. There are a few packages like actually hand calcs that doesn't work that well in Google Colab, I think. That one has some problems. It doesn't render nicely, but everything else runs in Google Colab.
Next question. Great presentation. What is your favorite FEA software in terms of how well it integrates with Python and how to automate model generation, running the model and extracting results?
This is a question I can't answer fairly because there are some softwares I've used a lot more than others. So for example, like I've used eTabs a lot, and I think eTabs works really well. The API has also gotten a lot better. The tabular format is really good. Then I know GSA is always amazing with their like so tabular, very clean tabular data. CA Engineer is the same. So I wouldn't say I have a favorite for this, and I also don't think that the Python incorporation should define the FE software because Python is going to adapt to your FE software. So Python, you can adapt your FE software, you can't.
By that argument, you could have a completely new software by using it with Python.
True. Yes.
Actually, yeah.
Yes.
Okay. Another question from Jack. Is it possible to use AI, and I guess by extension Python, to analyze photos and to separate them into different folders based upon which section of a site you're looking at? For example, groundwork, steelwork, concrete. So I guess this is Python and AI to analyze with code. Do you think that's possible?
I would be extremely surprised if it was not possible. But some of these image recognitions softwares, I don't know how exactly you would do it, but I would be very surprised if it's not possible.
Okay.
But it may not be great. I would be surprised if it's great, but I think it's possible.
Might need some practice. Okay. Next question. Writing code with AI. Do you have any recommendations for structuring, or do you feel as though typical pseudocode is sufficient to get started? Have you tried handwritten pseudocode / flowcharts?
Yes. So I can actually like tell my own journey there. So I got totally hooked on ChatGPT. when it came out, and I started using it more and more and more. Um, but I slowly found myself in a situation where I realized I had not actually thought my problem and solution through before I tried to prompt my way out of a solution. So I ended up spending much more time trying to debug code I barely understood to a solution that was poorly defined because of laziness. It's much easier to just prompt than really thinking your solution through. So I actually use AI less now than I did before, and spend much more time on not so much flowchart diagrams because they are like I use them, but I don't feed them to an AI because they don't. I have a theory that they don't read that as well as they do pseudocode. But the second you can define your solution with pseudocode, where you say, go in, find these columns with this. When you have found those, then do this to this column, do this to this column. And you can really put everything into if this, then that, if this, then that statements, then you can use AI. But yeah, be careful.
Okay. Another question. This is another software-based one. Do you use Python to extract results data from robot structural analysis? I think going back to the point we had earlier, I imagine if it's got an API, you probably can, and if it's in tabular format.
Yeah, I have never done it with robot, and I actually don't know much about robots API. I think it has one that you can connect to. I'd be surprised if it doesn't. But I've done it like, for example, with eTabs. It's been fairly okay to say, okay, I have eTabs open, connect to the open instance of eTabs and pull this data out. But most of the tools I use, I rely on manual export of data. It's amazing to connect directly to a model, but I kind of often feel safer if I have the Excel file. I can also, if I have someone coming over who does not have experience with a Python script and APIs, I can say, this is my Excel file. I can search in it. I can find this data I'm showing you. You can actually go in and QA the data without knowing any Python. So I'm just, yeah, mostly using manual export, even though it takes a little longer.
Okay. Another question I think would be quite beneficial for people starting out. How long does it take to learn Python for structural engineering applications starting from scratch? And specifically, how many hours in total of learning and practice would it take to reach a level where you can solve problems with Python in your projects?
So I would say, like, this is actually something I say I have some experience with seeing now. I would say you spend probably around 10 to 12 hours getting into the fundamentals. You're not good after that, in by no means, but then you can definitely write basic code. You can write these templates like where you loop over some certain calculations, and you can do quite simple things. But I would say after a total of 30 hours of studying and like practicing, you start to be decent enough to actually create something pretty useful. So yeah, 10 hours, you can start building tools. And after 30 hours, I would say you can work quite nicely with spreadsheets and some of these libraries and be a bit more confident with a lot of it.
Okay. I imagine this next question is program and software dependent. So the question is there any plugin option that we can use in the analysis software using Python programming?
I'm not sure. So I would say no because I'm not sure exactly what is meant with it. When we talk about like plugins for the analysis software, normally you have a plugin called comp types, for example, where you just connect to the software via the API, and that's the same library you use every time. Oh, I think if you can have a plugin inside the software where you can then trigger some of this code here. That I actually don't know. I have never tried it before, but I think mostly not, because most software is written in C sharp. And if you want to go into plugin development, you're going to start having like proper like plugin development, and it's a completely different level of programming and understanding. You need to have to do that. So I would say no. Like that should not be the goal here.
Okay. Question on your past project experience. Have you ever worked on any computational structural design projects? If yes, can you quickly share your experience? So out of all those nice pictures you showed at the start, were any of them computational structural design?
Yes, I had one which was a doubly curved, super thin concrete shell with an edge beam resting on 3D printed columns, where one part of it was outside, exposed to the elements and temperatures. The inside was not. Everything was doubly curvatured, weirdly in space and rotated. It's under construction now. It's actually happening. And there we built 100% computationally, like parametrically defined model, linked it directly to Strusoft Fem design, and used Python to compare, like, I don't know how many different models for sensitivity and all sorts of things. Um, Without Python, that would not have been possible. But they also used a lot of Grasshopper, which we're not touching here, and I don't think we should touch here.
Okay. I don't know if this comes under the category of structural analysis, but I think it's a great question anyway. It's from David. If I wanted to obtain specific information from various journals online, can I use Python to write a code for data scraping?
Yes, when I think so, if they are accessible without password. What I did when I was looking for a car, I was looking for a used car. I scraped this Danish database for used cars to compare mileage and price and location, and wrote a whole program to determine whether the price I was getting was good. So yes, you can do these kind of things. There's a package called Beautiful Soup that can help you with that.
Perfect. Well, I hope that answers your question, David. And if you can send me that car program, I wouldn't mind looking for that as well for some of the UK. I'll try and wrap up these last few questions because it is getting close to the finish now. Do you have any recommendations for generating calculation sheets as Word documents? What Python packages would you recommend?
As Word documents, see, that's a good question. That I actually don't know. I cannot answer that question. I've never done it, and yeah, I actually don't know. I would
Okay.
need to do some research for that.
Okay. Question from Mehdi. Python seems capable of doing extremely complex tasks quite strongly. Is there any limitations to Python from your experience of using it for years?
Yes, there are limitations. One limitation being often company policies. Um, it's you need to have access to and to install these packages unless you want to run it in Google Colab. Another limitation is that if you run it in Google Colab and you share it with your colleagues, it can be scary to run for a lot of people. Then there is this with or what we talked about before, like from making dynamic figures or something. Yes, that's also not ideal. Like it can't do everything, but that's why, like, I'm like, yeah, it's the glue that ties all your other software together, plus a bit more. But there are a lot of limitations. It's also difficult to just like package to a piece of software and ship it to people. You can do that to some degree, but yeah, there are definitely limitations.
Okay. Last question now before we wrap up. How do you decide if a problem is worth solving with code versus doing it manually? It's a big investment of time, but sometimes you might go down a rabbit hole.
This is probably the biggest thing that holds people back from becoming really good. Um, so sometimes you're like, hey, yeah, I'm going to spend a full day trying to automate this, only to find out that you don't know how. You end up having wasted a full day of work. There's a really real concern in automation. Um, how do I decide whether it's worth doing or not? Experience is one thing, or asking someone with experience. Um, and trying like if you know I need to go through step A, B, and C to do this, just try to get an idea first of all the steps. Like, what do you think is going to be the difficult parts? Write out all the parts and try to solve the difficult things. And then the unethical tip here is to when you get asked about how much time you think it's going to take, just say twice as long, and then start out by trying.
Perfect. Okay, I think that's a great answer to finish the presentation on. How many's here? 172. That's a great number, that. Thank you, everybody, for sticking with us. I hope you've enjoyed our presentation. If you do have any questions regarding Timo's course, he is contactable after the presentation, and we have recorded this and will hopefully either distribute on the iStratT's website or on YouTube. So once again, thank you, everybody, for coming.
Is it okay? Is it okay if I just quickly share my email over here? So if anyone want to write to me, just write my mail over here, timo@timoharboe.com. I'm seeing us sending a direct message. Yeah, contact me on LinkedIn, Timo Harboe Zollner. I think that's the easiest. You have my name up here.
Perfect. Right. We at the iStratT Northwest Young Members Group are also contactable on LinkedIn should you have any further questions, and keep an eye on the feed for further technical talks and site visits. I think that wraps everything up. So I'll just say, Timo, thank you very much.
Thanks for having me, and thanks to everybody for joining.